This is Josh. For the most part, Josh has been a pretty good roommate. However, he has one bad habit. He tends to leave the toilet lid up. Hi, my name is Ketan, and welcome to the Science Bros. Of course, I have asked Josh to put the toilet lid down, but as we all know, habits take a long time to form and break, so I decided to help him out a little bit using code. My plan is to use operant conditioning in order to encourage him to put the toilet lid down. This is a tried and tested psychological method to help a subject learn new behavior. When you hear the word conditioning, you likely think of Pavlov's dogs, where Russian psychologist Ivan Pavlov demonstrated that dogs can be conditioned to salivate at the sound of a bell if the bell was present when they received their food. However, this is an example of classical conditioning, learning via association. The dogs learn to associate the sound of the bell being rang with food being brought out. Operant conditioning is different in that it uses rewards and punishments to modify behavior. Behavior that is rewarded is likely to be repeated, whereas behavior that is punished is likely to not be. I'm interested in the latter. The plan is to play a loud, obnoxious sound whenever the toilet lid is left up. To do this, we'll use an Arduino to run the code, a breadboard to assemble the circuit, a force-sensing resistor to detect when someone is sitting on the toilet, a passive buzzer to produce the noise, and a crude switch to detect when the lid is left up. First, let's assemble the circuit. I will be using a breadboard to prototype this build as I don't plan on making it permanent. A breadboard is a plastic board with a grid of holes. The holes are connected with metal clips, allowing you to connect electronic components together. The power, red, and ground, blue, rails are connected to positive and negative voltage, respectively. You can connect components to these rails, allowing you to supply power to all components on the board without having to wire them up individually to power. Breadboards aren't meant for long-term use as the connections are not permanent and the board can wear out over time. You should instead use a more permanent solution, such as a printed circuit board. First, we'll connect the board to power. We can use a wire from the 5-volt pin and a wire from the ground pin on the Arduino to the positive and negative rails on the breadboard, respectively. Next, we'll connect up the passive buzzer. This is the component that produces sound when we give it a square wave signal. By changing the frequency of the square wave, you can change the pitch of the sound. Conveniently, the Arduino has a built-in function called tone that generates square waves for us at a specific range of frequencies. We can connect one leg of the buzzer to the ground rail and another to a digital pin on the Arduino, which we can control via code. Now, we will connect up the next most important part of the circuit, the force sensing resistor. But first, what is resistance? Electrons flow from negative to positive. The simplest electrical circuit is just a wire connected to power and ground. The wire will be made out of a highly conductive material that allows for the free flow of electrons between the ends. A resistor is a simple electrical component that resists the flow of electrons between its two ends. Basically, if you think of a wire as a pipe that electrons flow through, a resistor is a narrower pipe that restricts the rate at which current flows. The resistance of the resistor is measured in ohms, where the higher the ohms, the more current is resisted. A static resistor is simply a resistor that doesn't change its resistance over time, unlike our force-sensing resistor, which is an electrical component that changes the resistance it reads based on the pressure you apply to its head. To read the values from the resistor, we can connect a 10K ohm static resistor in series with the FSR to create a voltage divider circuit. If you would like to go more in depth with any of the stuff I've just talked about, there will be plenty of links down in the description below for you to do some further reading. The important thing is that now we can read the voltage output from this circuit via the Arduino's ADC. Analog to digital converters, or ADCs, are used to convert an analog value into a digital one. By wiring the A0 pin of the junction of the pull-down resistor and the force-sensing resistor, we can read it as a digital value in our code and do logic based on that value. We are now almost ready to start writing the code for this, but first we need a way to detect when the lid of the toilet is actually lifted. My first idea was to find out what values the force-sensing resistor read when the lid was down and the seat was down versus when the lid was up and the seat was down, but the FSR ended up not being sensitive enough to reliably tell the difference. Instead, I've opted to create a physical switch that closes when the lid is up. The switch is simply two wires, one connected to ground and one connected to a digital pin on the Arduino. Both of these end in squares of aluminum foil, which because it is conductive, I can wrap the ends of the wire in the foil to increase the effective surface area of the wires, allowing for more reliable detection of when the lid is actually up. I'm also going to include a simple one-wire switch that I can unplug from the breadboard if I don't want the code to actually run. For example, if I have company over and don't want them to be surprised by a loud buzzing noise if they leave the toilet lid up for too long. Now let's go ahead and jump over to the code to finish the implementation. However, rather than step through the program line by line, let's instead look at a high-level overview of how it works, and I will leave a link to my GitHub in the description below if you want to take a look at it for yourself. So, the code is structured as a state machine, which may sound complicated, but it's actually pretty simple. So let me explain. The toilet has 4 possible states. It can exist at any point in time. First, we have lid down, where both the lid and toilet seat are all the way down. Seat down, where the lid is up, but the seat is down. Sitting, where the lid is up and someone is sitting on the toilet seat. And lastly, up, where both the lid and seat are up. So, a state machine keeps track of which state we are in at any given time and lets us do something based on the transitions between the states. To complete the state machine, we need to fill in all possible transitions. From the lid down state, we can get to seat down if the switch detects that the toilet lid is open and the FSR detects that the toilet seat is down. We can get to the up state if the FSR detects the toilet seat is not exerting any pressure on it. From the seat down state, we can get to lid down if the switch detects that the toilet lid is not up, and we can get to sitting if the FSR detects that there is enough pressure for someone to be sitting on the seat and the switch detects that the lid is open. We can also get straight to up if the switch detects that the seat is up and the lid is up and the FSR detects no pressure from the seat. From up, we can get back to lid down if the FSR detects that no one is sitting on it and the switch says the lid is down. And we can get to seat down if the FSR detects that the seat is down and the switch detects that the lid is up. This transition is one of the times where we start the timer for the buzzer. From sitting, we can cross to lid down if the switch is closed and the FSR detects that no one is sitting on it. And we can get to seat down if the FSR detects that no one is sitting on the seat and that the lid is still up. We can also start the timer during this transition. And finally, we can get to up if the FSR detects no pressure. Now that we have all this diagrammed out, it should be pretty easy to transfer it all to code. The reason we have a timer built in, as I mentioned on some of these transitions, is to give the user a bit of a grace period so the buzzer doesn't start immediately without giving them enough time to even pull their pants back up. Okay, so now the code has been written. Once again, it'll be linked in the description below if you want to check it out for yourself. So now it's time to actually install it in the bathroom. First, we'll go ahead and plug it into the wall outlet. Now we can run the wire under the counter and keep it neat with some duct tape. We'll also duct tape the breadboard to the wall to keep it close to the toilet. Next, we tape up the makeshift switch that closes when the toilet lid is up. And finally, we tape down the force sensing resistor and we're done. All that's left is to test it out. Alright, and that's pretty much going to do it for this video. I hope you guys enjoyed. If you did, please remember to leave a like, comment, and subscribe if you want to see more content. And this video was just for fun. Josh has been a great roommate.